science works! The idea of elements first came about in 300 BC when the Greek philosopher Aristotle introduced the idea that everything on Earth was made up of elements. Aristotle suggested a tetrad of elements: earth, fire, water, and air. He also believed that each element could either be hot, wet, dry, or cold. In the 18th and 19th centuries, several elements were being discovered almost every decade. These soon began to provoke questions such as, how many elements were there? And had most of them already been discovered? The modern periodic table arranges the elements by their atomic numbers and periodic properties. For over almost a century, several scientists work hard to assemble the known elements in the format we use today. But among these men, Russian chemist Dmitry Mendeleev is called as the father of the periodic table because he was able to predict the properties of the undiscovered elements during his time. Elements may be categorized according to groups or element families. Knowing how to identify the group where each element belongs to helps recognize their properties, predict behavior, and their chemical reactions. An element group or family is a set of elements sharing common properties. This may be used since the three main categories are very broad. The vertical columns, represented by the numbers 1 to 18, categorizes the element groups or families. The characteristics of the elements in these families are determined primarily by the number of electrons in the outer energy shell. The alkali metals are recognized as a group of elements. These elements are metals except for hydrogen. While hydrogen sits on top of group 1, it is not an alkali metal because the gas does not exhibit the typical properties of the group. Hydrogen is a special element which shares similar properties with group 17 or 7A elements. Group 1 or 1A alkali metals with one valence electron, soft, metallic, shiny, and lustrous solids. Has high thermal and electrical conductivity, low densities, and relatively low melting points. Rigorous exothermic reaction with water produces hydrogen gas and an alkali metal solution. Ionize to lose their electron, so the ion has a positive 1 charge. The alkaline earth metals belong to group 2 or 2A. They have 2 valence electrons. Metallic solids, harder than alkali metals, are shiny and lustrous but oxidizes easily. High thermal and electrical conductivity, has higher melting points, and are denser than alkali metals. Ionize to lose their electrons with ions of positive 2 charge. The largest family of elements consists of transition metals, which occupy the short columns at the center of the periodic table. The groups 3 to 12 transition metals are shiny, lustrous, hard metallic solids. The D and F blocks have 2 valence electrons, has high thermal and electrical conductivity, are dense, and with high melting points. Large atoms exhibit a range of oxidation states. Group 13 or 3A is the boron group or earth metal family, each with 3 valence electrons. Elements in this group have diverse properties, intermediate between those of metals and non-metals. Aluminum is a familiar member of this family. The carbon family belongs to group 14 or 4A. They are also called as the tetrals, which refers to their ability to carry a charge of 4. Just like group 13, the elements in this group has diverse properties which characterizes both metals and non-metals. Carbon is a famous member of this group capable of forming 4 bonds. In group 15 or 5A, the pnictogens or nitrogen group is a significant element family with nitrogen as its well-known member. Nitrogen group contains 5 valence electrons and has diverse properties in between metals and non-metals. The most essential gas to living organisms, oxygen, belongs to group 16 or 6A. This group is also known as the chalcogens, having 6 valence electrons. Diverse properties are also observed, changing from non-metallic to metallic as you move down the column. Group 17 or 7A contains elements of the halogen family, a group of reactive non-metals. They have 7 valence electrons and high electron affinities. Change in state as you move down the family, with fluorine and chlorine as gases at room temperature, while bromine and iodine are solids at room temperature. The noble gases or inert gases of group 18 or 8A is stable with 8 valence electrons. The elements in this group are non-reactive non-metals, typically existing as monatomic gases. They exist in trace elements and rarely form compounds. Reading from left to right across the horizontal rows is the period or series. There are 7 periods in total, where each element having the same number of atomic orbitals or shells are placed side by side. The last 2 rows below the periodic table are the lanthanides and actinides. It contains radioactive elements, especially useful in nuclear reactions, and emits high radiation. Elements in the lanthanides and actinides are also called inner transition metals since they are mostly metallic in nature. You can find an element using the group number and the period number. Let us consider the following examples. The element groups and periods indicate the similar characteristics of each element in the periodic table. This makes trends in element properties apparent and easy to understand. It also provides useful and important information to understand chemical bonds and chemical reactions. Don't forget to like, share, subscribe, and hit the notification bell for more science lessons. God bless!